Good morning, everyone, and thank you for joining us in this webcast, Top Deployed SD-WAN Use Cases. Before we get started, I just want to mention a few things. So for those of you that attended the Future WAN Summit, this is a continuation, a part 2, if you will, of the live demo webcast presented during the summit. Now, don't worry if you missed the previous live demo, as this session will just be covering additional SD-WAN use cases. If you do, however, enjoy today's session, we, of course, encourage you to check out the previous live demo webcast, which, along with the other Future WAN Summit sessions, can be found at viptela.com/futurewan. Now, our presenter today is David Klebanoff, who is the Director of Technical Marketing here at Viptela. Now, just before I turn it over to David, I'd like to point everyone to the Q&A box, and we encourage you all to ask questions, which David will try to get to at the end of the webcast. I'd also like to point you to the attachments section, where you will find a link to the Future WAN Summit page, as well as an 11-question peer insight survey on WAN. So if you're able to take a few minutes to fill that out, that'd be much appreciated, and you will receive a copy of the results. Now, without further delay, I will turn it over to David. David, take it away.
Hi, thank you very much, Rachel. Right, everybody, good morning again. So we are here to talk about top deployed SD-WAN use cases. As Rachel mentioned in the introduction, we are continuing our conversation around top deployed SD-WAN cases. We have done part 1 during the SD-WAN Virtual Summit just 2 weeks ago. You are more than welcome to go and follow this link after this webinar and just listen to that session. It's an hour-long session that gives you 4 use cases, and we're going to continue and build beyond that. So we talked about transport independence. We talked about how you build and integrate into the existing environment. We talked about regional security, and we talked about the regionalization of internet exit points. These were all top use cases in a previous session, and today we're going to continue and build on those, right? So as last time, let's look at the demonstration topology and sort of a customer journey to implementing those features. So the 4 things have already been implemented. We've again talked about MPLS to hybrid. We talked about a brownfield integration. We talked about regional internet exit, and we talked about regional secure perimeter by inserting through service chaining, a firewall, and an IDS appliances. Now, the next step, we're going to talk about cloud security through Viptela's integration with Zscaler. Then we're going to turn to a hybrid cloud through an integration with AWS. Viptela integrates with both AWS, EC2, and Microsoft Azure. This time we're going to talk about an AWS integration. Then we're going to talk about connecting to business partners, and not just business partners, but in this case we're going to look at business partners, but it's a vast connectivity options outside of your organizations once you're deploying an SD-WAN solution, how you can accommodate connectivity to other entities which are external to your organization. And again, we're going to look at business partners in this particular session. And at the end, we're going to look at something very interesting, pretty unique, of streaming digital content, which is something that we're seeing in some of our customers, and that's going to be a pretty interesting use case. We're going to wrap up today's session with that use case. So let's start talking about cloud security integration with Zscaler, that's going to be the area of focus, right? So if you look at before we jump into the actual use case, if you look a little bit about how the connectivity into the cloud applications and the cloud resources was accommodated in legacy environments, then you really are looking at 2 different models. You have the data center backhaul model, where you primarily relying on the MPLS network for connectivity from your branch offices into your data centers, and that is where your connectivity to the cloud resources is provisioned. So of course, to secure that access into the cloud resources, most of the customers are putting firewalls in there, right? So what you're having here, you're having a data center backhaul into the organizational enterprise data center where the traffic is inspected by the firewall before it's given to the cloud resources. The second model is direct internet access from the branch offices. That's where the organizations are having direct internet access into the internet from the branch offices. And again, since those branch offices now become internet access points, it needs to be secured. So the traditional way of securing those is to provision a firewall in every single branch office, right? Of course, for obvious reasons, you may get a more optimal path, so you're not backhauling the traffic to data center anymore, but you are adding to your footprint in your branch offices. You are relying on quite a few firewalls, basically as many firewalls as you have branch offices, which is costly to procure and also costly to manage. So as applications are shifting more to the cloud, so is the security approach of how to secure that access to those cloud applications is also morphing, right? And when you talk about an SD-WAN and how SD-WAN can embrace the cloud security, and this time it's a cloud security with Zscaler, you can see that there are two approaches again. There is an approach on the left that is a regionalization of a cloud access, which is, you can think about as a regionalized cloud path, where you have sites or branch offices which are provisioned for an SD-WAN fabric, yet they're not having a direct access into those cloud resources. And the traffic is sent to the regional hub locations, and from the regional hub locations, it is forwarded to the Zscaler enforcement nodes, where the security posture is enforced and security is done, right? So this is the regionalization of the services for the organizations that are not quite ready to open the floodgates and allow every single branch office to connect into the internet with direct internet access. On the right, you see a more optimal way where every single branch is allowed direct internet access connectivity into the Zscaler enforcement nodes, which are spread across every geography, and that traffic goes direct from the branch offices into the Zscaler cloud, where it gets inspected and gets subjected to the security policy that the enterprises are looking for. So that's really the transformation of security posture from being in on-prem physically at most and to the cloud-based security, which is both regionalized or direct access. Now, what are the deployment options for the Zscaler cloud security, right? And here you have a choice. It depends on how your site is built. If you're looking at data centers or regional data centers, you're mostly talking about two SD-WAN appliances that have connectivity into the SD-WAN fabric, also have a connectivity into your core routing infrastructure and integrates with OSPF or BGP or both into the core infrastructure, and each device is provisioned with a tunnel into the Zscaler enforcement nodes. That deployment is best fit for regional data centers or main data centers or maybe very large campuses, right? The mid one is the large campuses where what you can see is large or mid-sized campuses where you can see it's very similar to the drawing on the left. The only difference is basically the LAN side of the integration. Instead of using routing protocols, it uses gateway redundancy protocols such as VRRP for high availability. And again, you have tunnels in redundant fashion that are provisioned into the Zscaler enforcement nodes. Now, on the right, you see the remote location, which is going to be the case we're going to discuss, where an organization opts into not having a redundancy on an SD-WAN appliance. You can see there's a single SD-WAN appliance provisioned there. Yet it has two tunnels to two different Zscaler enforcement nodes for geographic redundancy. So you have redundancy on the security standpoint from the enforcement node standpoint, but you don't have the redundancy on the SD-WAN side. And again, all three are valid deployments, and we have plenty of deployments for each one of them, right? Now, if we look at our specific demo in here, as I said, we are going to examine the branch office model, where we have two VPNs, VPN 1, VPN 2. You can think about VPN 1 as something that services guest Wi-Fi users. You can see VPN2 something that services corp users. The traffic out of these VPNs have different sort of patterns. The traffic from VPN1 is going to go through the tunnels into the Zscaler for the policy enforcement. The VPN2 traffic is not going to go through the tunnel to the Zscaler. It's going to basically go through an SD-WAN tunnel into the SD-WAN fabric to the rest of the organizational network. Right now, the traffic segmentation is performed on the Viptela vEdge device. The security policy is enforced on the Zscaler cloud security. Now, what we have is we have deny peer-to-peer file sharing policy from the Zscaler, which prevents access into, let's say, sites that such as BitTorrent, and that would be sort of your way of kickstarting the peer-to-peer file sharing, right? So let's get into the actual demo. And so let me look at vManage, right? For those who have watched our previous videos, vManage is a single pane of glass for all the management, monitoring, troubleshooting, all the operational tasks that you perform on the Viptela system, right? So let's go into the configuration. Let's look at templates, and there's a template here that you can see. It's called Remote Site. That template is, if we look at which devices it's attached to, it's attached to several devices. So if I look at the actual properties of the template, I can see that two GRE interfaces have been attached to this template. And if I want to see the actual GRE configuration, I can go into the feature. Let me just quickly search for GRE. Here are the two GRE feature templates, and if I look at them, I will be able to see inside all the characteristics that you need to build the GRE tunnel to Zscaler POP. In this case, this GRE tunnel goes to the Zscaler POP in San Francisco. It uses its source interface as Gigabit Ethernet 02 on the vEdge appliance, and the destination of the tunnel is this IP address, right? So the second GRE tunnel would have the same characteristics. Right. Now, if you want to see the status of the GRE tunnels, I can go into the monitor. I can go into the network. I'm going to choose the remote site 1 vEdge. I want to run a live query against the device and basically have it display to me all the GRE tunnels that are provisioned on the device. As you can see, we have two tunnels on that remote office that are GRE1 and GRE2, and they are connecting to two different destination IP addresses, which are the IP addresses of the Zscaler enforcement nodes in the cloud. Of course, they're upstate, right? So let's actually make some policy push and make sure that this traffic goes into the Zscaler enforcement points. Just because we have GRE tunnels doesn't mean that we are still sending the traffic there. Before we do that, let me just hop into this desktop in here. So this desktop is think about this as a client which is connected behind the vEdge in that remote site, and this is everything we're doing here is going to go through that vEdge appliance that we just looked at and onto the network, right? So before we actually shift the traffic to Zscaler, let me just quickly open a terminal window in here. Let me just start the continuous ping to a DNS server. Right, let us just run. We'll come back to this screen. As you can see, this connectivity is going. Right now, it is not taken as Zscaler. Right now, it's actually going through a main data center. So this is traditional sort of way of delivering security through the main data center. Now, I want to embrace the cloud security. So let me go back to vManage. Actually, before vManage, let me just browse and see that we have access to all the resources. For example, I go to ESPN. You can see that I get an ESPN website, and then I go to the BitTorrent, and I get a BitTorrent website. And that's exactly what I want to prevent. I don't want that site to open. I want to make sure that my URL filtering policy blocking this website so people are not consuming a peer-to-peer sort of networking, right? I can, of course, block many things, but just for the simplicity of the demo, we're just going to do a simple URL policy. So now I'm going to go to the vManage, I'm going to go into the configuration, and I'm going to go to policies. And we have the policy that was created ahead of time. So let me just go and activate this policy. So now what happens? The policy gets activated on the vManage. So once it's activated on the vSmart controllers, and it's enforced on the vEdge appliances. In this case, it's going to be the appliance at that remote office. And of course, think about this as we are applying this onto one branch, but the policy, Virtualized policy framework, is a very scalable framework. It allows you to define the scope of the policy, and the scope of the policy could be in individual sites, which is what we're doing right now, but the policy could also span the entire network. So by just applying the policy, I could implement the cloud security over my entire SD-WAN network. So now the policy has been implemented. So let me go back into the desktop and just refresh the page. Of course, I get this pop-up that says security violation has occurred. It is not allowed. You're not allowed to browse a peer-to-peer site, and that's exactly what we were after, is to make sure that we are the content that we would like to block is blocked, right? ESPN, of course, is still accessible, and it passes through the Zscaler. The Zscaler policy does not block this traffic, right? So we achieved exactly what we wanted to do. Now, if we quickly open that the terminal window we had running in here, and we'll just stop it. Just as an interesting observation, you can see in here is 0 packet loss, right? So what happened is that we have shifted the traffic from passing through a main data center, like through a backhaul into the main data center, and having this traffic take a direct internet access directly from the branch office into the Zscaler cloud, and we did this with 0 packet loss, right? So that is something that many of our customers are very important consideration for our customers because when you're deploying SD-WAN, when you're deploying an enterprise-grade SD-WAN, you are anticipating and you're expecting the features to be scalable, reliable, and that's exactly what we're doing here with the activation of a cloud security. So let me just, while we transition to the next use case, let me go to the policies and just deactivate this policy so we can get ready for our next use case. Right? Awesome. We'll just let it run, and let's go back into our use case. So the next one we're going to talk about is hybrid cloud. What we're talking about hybrid cloud, when we're talking about hybrid cloud, we're really talking about a connectivity into the AWS and the extension of your compute footprint from your on-prem data center into the AWS VPC EC2 instances, right? So it could be that you're doing a hybrid cloud in a sense that you are distributing the resources between an on-prem and a cloud location. But at the same time, some organizations really take it a step further and moving all of the resources, in which case it becomes not a hybrid cloud, but rather a complete sort of a public cloud, where you're moving your entire data center resources into the AWS environment. Whatever the case may be, the philosophy that we have for an adoption of a public cloud is to create a seamless experience whether your resources are located in your enterprise data center as your private cloud, or if your resources have now transitioned into the public cloud instances with AWS or Microsoft Azure. What Viptela does, it gives you a seamless experience of extending your SD-WAN fabric all the way from the branch offices to the corporate data centers, to the regional data centers, to the cloud destinations. All of that is one seamless SD-WAN fabric. right? So we of course extend all the SD-WAN features through that fabric, such as, for example, a very popular feature of segmentation. So if you had segmentation into lines of businesses at the remote office, or you had a segmentation into sort of an organizational unit in your branch offices, and that segmentation was carried over into your enterprise data center, what we want to make sure is the same segmentation is now carried into your cloud data center as you are moving or transitioning your resources, or maybe commissioning new resources in the public cloud. So the features of segmentation, transport agnostic, hybrid transport, application visibility and control, all of those things are inherent features of an SD-WAN fabric, and the Viptela's philosophy is to seamlessly enable those throughout your fabric, wherever that fabric is, even if it gets extended into the public cloud environment. Another element is the shortest network path to reach those resources. If you are moving your resources from the private cloud into the public cloud, you don't want to incur any additional latency by backhauling your traffic into specific choke points in your network to before your traffic arrives at the public cloud. Viptela philosophy is to provide you the shortest network path between your users, which are at the branch offices, and your cloud resources, which in this case are in your AWS. No backhauling, no swinging through sort of a midpoint choke point, straight connectivity from the branch offices into the cloud. Now, for our demonstration, we will consider that we have an existing sort of SD-WAN network, and we are commissioning a vEdge cloud, which is the software instance of the Viptela vEdge SD-WAN appliance. Think about this as an NFV instance of Viptela SD-WAN appliance that gets commissioned in the VPC, in the AWS VPC, and it front ends the compute resources that are in that VPC, and again, it extends all of the features of the SD-WAN fabric seamlessly into the AWS, and the connectivity is just a straight connectivity between the remote sites into the AWS environment through a direct cloud path. Now, of course, if you deploy this in multiple AWS VPCs, all of those VPCs will join the SD-WAN fabric, and you'll just have one cohesive fabric that extends from your on-prem data centers or on-prem branches and into the public cloud VPC instances, multiple instances. And you can even do a multi-cloud in the sense of you can extend the same SD-WAN fabric between a single instance on AWS to multiple instances in AWS, and also instances on Microsoft Azure. So you start being sort of a cloud agnostic, and you don't really pay attention to which cloud the connectivity extends to. From the SD-WAN perspective, it gives you the same seamless experience. So let's go back to the vManage. All right. And from here, let's navigate into the configuration, and let's navigate into the devices. You see a device in here that's sort of in this state where it doesn't really have its host name, doesn't have any system IP, doesn't have site ID, doesn't have any characteristics in it. Now, what is this device? If I were to look at the AWS console, so this is the EC2 console. We actually have the vEdge cloud running in there, and there is one single VM behind it. Just for the demonstration purposes, of course, it's a very simplistic environment. And so this is the vEdge cloud. Now, vEdge cloud has been provisioned in a system, yet if I go into back into the vManage, and I go into the configuration and certificates, you can see that the certificate that was given to this individual vEdge is actually marked in an invalid state, which means that the system does not trust a certificate that is installed in that vEdge cloud virtual appliance. Every appliance comes with physical appliances come with pre-built certificates that are inserted into the TPM module during the manufacturing process. For the virtual instances, which is exactly what gets installed in the public cloud, the certificate is allocated, so it's not a built-in certificate, it's allocated. However, you can see that it's been put into sort of an untrust mode, which means that device is not allowed to be admitted to the network. Before I activate this device, if I also quickly go into the geography, I'm expecting this device to be somewhere in here in a Portland area in Oregon. Of course, you see there's no device in here because it's sort of an untrusted device, so it's not one of the managed devices yet. So if I go back into the certificates and I just flip this into valid, and I say yes, and I say I want to propagate this into the controllers. So now the knowledge that this device is a valid device is going to get propagated throughout the control infrastructure. And once it's completed, you see that now all of the devices, they now have all the control elements now have the knowledge of this device, right? If I go back into certificates, it's now see that the host name has been recognized, the IP address of the system has been recognized, and it's now in a valid state. Now, if I go into the network, I can now see this device also appears in here on AWS as an AWS sort of host name. If I go and I can see it's been already building control connections through the internet because that AWS instance is connected through the internet. It's already building control connections to all the control infrastructure. And of course, if I go back to the geography, I can see this device also appeared in here, and I can click on it and I can request it to show me all the links that has been provisioned. And as you can see, it's part of the fabric. It's connected to the rest of the sites. So that is how you seamlessly extend your SD-WAN fabric into the public cloud environments. All right. Let's move on to the next case. Business partner connectivity. So business partner connectivity is an ability for you to extend your organizational fabric into the external entities. And now what those external entities are, they could be suppliers, they could be partners, they could be part of mergers and acquisitions, and they need access into your protected application resources in your data centers. Now the question is how are you going to accommodate that connectivity, because they're not fully trusted entities, right? So Viptela's philosophy is to regionalize access into those protected applications in the data center. There's multiple ways of doing that, but in this case, we're talking about regionalization of the services. In those regional hubs, you can provision firewall devices, and those are going to enforce the policy for connectivity from those external entities into your protected applications. So effectively, they are creating a shield and a controlled access around your organizational, around your enterprise protected applications, and allowing only selective access to suppliers, partners, or entities that has been acquired, right? There's quite a lot of sort of examples of where that could be useful, but suppliers, partners, mergers and acquisitions, spin-offs, these are sort of the most predominant cases that we're seeing being deployed. Now, there's quite a few elements that go into the business partner connectivity. It's sort of easier said than done. You're thinking that, oh, I only need to provision connectivity to the partner, I need to send them through a firewall, and that's it. But in fact, it's a convergence of different things that you would want, or different features that you would want to implement in order to make it a whole solution, right? And here you're talking about segmentation, make sure the partner gets sort of compartmentalized into their own segment. The ability to do a per segment topologies, in the sense that once they are in their segment, you don't want that segment that they're in to span your entire network, because again, if you remember, we are talking about taking the partner traffic to the regional hub facilities and not to the rest of your organization. So just because they've been provisioned an SD-WAN appliance doesn't mean that they now have full unrestricted access to all of it, right? We want to make sure that the topology they're mapped into is a unique topology between that partner and only between your hub, between that partner and your hub locations, and not your entire network. Now, once they've been provided connectivity into that hub, an ability to do service insertion or service chaining through one or more service nodes, there could be a requirement for network address translation in case that partner actually uses an IP space that you are also using. You can't really force your partner to re-IP just because they need to connect to you. And the ability to send the traffic between multiple VPNs and inter-VPN traffic to make sure that you have connectivity from the partner VPN into your corporate VPN, yet it's subjected through the firewall, by the firewall. The policy gets sort of subjected in the firewall through the service insertion and service chaining. So in our case, what we're going to do, we assume that we have an existing fabric. We have a data center site that hosts the business partner portal, which is basically just a web portal for our case. We are provisioning a regional SD-WAN hub site where we're going to have a Palo Alto firewall that is connected through a trust and untrust interfaces into the regional SD-WAN, Virtualized SD-WAN appliance in that regional hub. Then a vEdge is provisioned at the business partner facility. The topology, a point-to-point VPN topology gets established, and it's important for me to emphasize here, we're not talking about here provisioning a one-off point-to-point IPsec tunnel between the two devices. We're talking here as a same fabric and the ability to segment that fabric and create a point-to-point topology over this fabric, so you don't have to treat this connection into the partner as sort of a one-off onboarding. It's the same experience, same management tools, same configuration and troubleshooting tools. It's just segmented off, different topology, service chained through the firewall, so the connectivity from the business partner into the business partner portal in the data center is going over this sort of secure, isolated path, right? So that's what we're set to do. Now let's go back into the system. All right, let's look into the network. As you can see, there's a B2B partner device that has been provisioned in the system. That is the device that you have shipped to the business partner. They have been provisioned in the system, yet they have no connectivity into your environment. So if I look for a second here in the geography, and I look at the B2B partner, this is the device, it's a managed device, and I looked at the links from this device, I can see that the IPsec tunnels have been established, so it's part of the network. Yet, if you remember, segmentation comes into play here, and it makes sure that the traffic from that site or from that partner site, even though the tunnels have been provisioned, the VPN traffic is not allowed to be sent on any of these tunnels because it's been isolated into its own VPN. Another thing to look at here is that you can see a data center, and you see this line between the B2B partner and the data center. So this data center has a tunnel right now between the B2B vEdge and the data center vEdge. So keep that in mind, that we have this connectivity that is now enabled, but again, yet there's no connectivity. Now, if I want to go and I want to see the from that device perspective, from the B2B partner perspective, let me just run a real-time query of how does the IP routing table look on that device. What I'm going to see is I only see connected routes, right? Of course, there's one default route, a static route to get me sort of access into the internet, but I don't see anything else except the connected routes. So you see that VPNs have been provisioned. The device is fully managed. I can collect statistics about it. I can trust or untrust it. So it's a piece of my infrastructure, yet no reachability information has been propagated to this device, and the device has no connectivity. And of course, if I go here and I just quickly browse into the business partner desktop, so think about this as a desktop connected behind this B2B partner vEdge appliance. And if I go here and I try to navigate into the business partner portal, that should not have happened. Okay, that probably was cached, right? All right, that was cached. You see that the page is not available. I'll just do another refresh. There is no connectivity. It was an artifact of a previous testing. So the web page doesn't open. There's no reachability, and as you had seen, there's no connectivity. There's nothing in the routing table to advertise the data center prefix. The data center prefix is 192.168.4.0. You see, it's not on the table. So if I go into the policies, and I apply a policy that we have prepared ahead of time, and that policy activates quite a few features in there. It enables communication between different VPNs. It enables service chaining through the firewall. It enables the connectivity into the business portal in the data center. So there's quite a few features that are in that policy to make it happen, right? It also defines a different topology and converts that from a sort of a topology of a full mesh into a topology that is only extended into the regional hub facilities and not the corporate data center, because we want to prevent the communication, direct communication from the remote B2B vEdge into the data center vEdge. So we just wait for another second for this thing to complete. Then we can examine the routing table again, and then also test that the firewall has seen this traffic. So now you see it's been propagated. So if I go back into the network, and I again choose the B2B partner, and I go into the real-time statistics or real-time information, and I say, show me the IP route information. Here's exactly what we were expecting to see. The 192.168.4.0 route has been advertised through the overlay management protocol, which is Virtualized control channel, control plane protocol. You can also see that it's available from the 10.10.10.15 site. If I quickly go into the site, I can see the data center is 10.10.10.14, and 10.10.10.15 is actually a regional hub. That's exactly what we wanted to do. We wanted to advertise this data center subnet, yet make it available from the regional hub, so the traffic that is destined to the data center is actually attracted by the regional hub facility. If I go into the business partner, you can see the site has already opened, and I have access into the web portal in there. Now, if I go quickly into the firewall, there's a Palo Alto firewall that has been provisioned in this topology as well. It's connected into the regional hub. It's connected to the vEdge in there, in the regional hub facility. So if I'm going to log into the Palo Alto firewall, just give it a second. And then I'm going to go into the monitor tab. You can see in here, this is the traffic that we just generated, right? It matched the rule, and it was traffic on port 80, and it got allowed. And if I go into the policies, then this is exactly the policies that got matched. We allow the web traffic to go in. Of course, I could have made it very granular and allow only the services that I wanted to be extended, or to be allowed to be connected to from the business partner. So as you can see in here, it's a very convenient way for you to extend your organizational SD-WAN connectivity into the external entity, business partners, suppliers, yet you're extending connectivity in a very secure and granular way, and allows you the full range of controls of how that connectivity, once the connectivity has been established, allows you a full range of control to send it through the service chaining or service insertion policy into the security enforcement. In this case, it's a Palo Alto firewall, and actually have a security policy enforcement in there, right? So it's a very useful, scalable way that our customers are deploying that. And again, regionalization of those services is also possible. You can have some partners go to one regional hub, some other partners go to another regional hub.
Thank you, everyone, for joining us today. And as mentioned, please do visit the Future WAN website. And if you do have any further questions, feel free to contact David directly. And again, thank you very much for joining us today. Have a great day.
Thank you.